fairly good confidence those individuals who will be our future math scientists in top-ranked departments at age 13. Finally, for some discriminant validity, if you look at this slide, or look at the previous slides, that is, you saw that some of the people were in those social science areas, law, business, and so on. Well, within our samples, although we primarily have focused on mathematically talented students, within our samples we have individuals who are primarily verbally talented. And the question is, what are the career choices of those individuals? When we look at the career choices of those individuals, what we find is that the verbally talented among our group are the ones that became the lawyers and the businessmen. Thus, I feel that we have pretty powerful data that speaks to that certain environments attract certain people, and that certain people are attracted to certain environments. And for the physical sciences, the type of individuals that seem to find the physical sciences appealing, satisfactory, so on, are individuals with high math and spatial abilities and very high theoretical or investigative preferences. And we can identify these individuals at age 13 and fairly well make a prediction about their career choice. And a lot of people think of psychology as a soft science. I get ribbed about that a lot. But I think what this speaks to is the power of psychology and what its variables can do. We may be a soft science, but that doesn't mean we don't have powerful variables that we're dealing with. And finally, as if I haven't given you enough to think about here and ponder, and I'm certainly open for alternative interpretations. As I told you before, I'm not used to having people readily agree with me. Let me just give you one more thing to think about. If you can turn on the lights, we'll put on the overhead, turn on the slide. I'm going to put this one up and conclude my talk with that. I'm not going to go through the 10 years of work that brought me to this picture here that actually came in the mail 2 days ago to me. But it is 10 years of work that has led to this picture. What you see here on this picture is a hemispheric activation patterns. And what you see here is a gifted brain, you may say so, and an average ability brain. Here's the male, here's the female. What we're looking here is the individuals, first at a baseline. We're looking at a blank slide, so what we kind of knew what they did normally. Then they were asked to process some spatial stimuli. Then what we did was as they were processing the spatial stimuli, we read through the EEG their hemispheric activation patterns. And if you look at this slide here, or this picture right here, what you can see is that different parts of the brain in the mathematically talented child is active than in the average ability child, and there's also gender differences here. What we find with a mathematically talented male at age 13, and we've now replicated these findings, so it's not just for one group, we've replicated it, is that mathematically talented males have unusually active right hemispheres. And what you see here is the lighter it gets, the more active that part of the hemisphere is. So here, left hemisphere, right hemisphere, you can see when they're processing that spatial stimuli, what you see here is that the male brain is very active over here in the right hemisphere. The female brain, kind of, you can just look all over the place. You can see it's a little different. So what we have found here is that there is a biological basis, or There's a biological basis, at least at age 13. How that became biological, we can't determine. It's probably an interaction with the environment. But maybe a physiological basis here. And it says that basically mathematically gifted males are using different parts of the brain when they're processing stimuli. And I guess with that thought is where I will conclude tonight's talk. Thank you.